This is a walkthrough for the spectrophotometric analysis part of the copper amine synthesis lab. Step 1 is using the stock solution that you created during the copper amine synthesis part of this lab to create 3 serial dilutions. You will also be provided a solution of unknown concentration. Transfer all of your solutions into cuvettes. This includes your known and unknown stock solutions of your copper amine, as well as your 3 serial dilutions. Don't forget to make a blank solution. This solution is used to ensure accuracy in your data. After you clean up your station, you're now ready to use the mass spectrometer. The room is located down the hall in room 360. Remember, before you put any solution into the machine, make sure that the cuvette is wiped down, as well as the solutions inside of the cuvette should be clear and not contain a precipitate. Now you can begin actually using the machine. After you're finished wiping the cuvette with your blank solution in it, you're going to load the solution into the machine. Do this by opening the top door of the machine and placing the cuvette inside. Then slide the door gently closed. Be sure your cuvette is all the way in there before you slide the lid of the machine closed. Now, using the program on the computer, you're going to zero the solution. All you have to do is press the button that says 0. The machine will ask you to save the file to the computer. You can save the file under any name. Just be sure it's appropriate. After that is done, the machine should start graphing. Your graph might have a few outside bumps in it due to various factors. However, for the most part, your absorbance value should be 0. Take the blank carefully out of the machine and move on to your next step. Next, you're going to repeat the same thing, but with your stock solution. There should be a curve on the graph. You want to find your X value at the relative max, not the absolute max. This is the wavelength you will be using for all of your absorbance measurements. The reason we scan such a wide variety of wavelengths is because this is the visible light spectrum. This spectrum provides a peak, which is called our lambda max. This is when the substance absorbs the most light. This number is what we will use to find the absorption. Now that you know that, record this value in your lab notebook. Now you are ready to actually measure the absorbance values of each solution. To do this, you use a different program, but you use the exact same steps as before. Don't forget you need to take the absorbance value of your stock solution as well as your dilutions, and before everything else, test your blank solution as a reference. Be sure to set your wavelength to your lambda max and follow the exact same steps as before, with wiping down your cuvette, opening the machine, and closing the machine. Again, repeat for all of your dilutions and your stock solution. When you're finished with all your experiments, your values should be listed on the computer like this. Record all of your values into your lab notebook. Clean up your area, and then move back to the lab to finish your calculations. First, you want to find the molarity for all of your serial dilutions. For this lab, you can use the M1 times V1 equals M2 times V2. Second, you need to graph all of your data. Your absorbance values will go on the y-axis, and your molarity values will go on the x-axis. You can use an online computer program for this. Our group used Microsoft Excel. The last thing you need to know about this experiment is you need to understand the relationship between absorbance and molarity. This law states that there is a linear relationship between absorbance and concentration, aka molarity. So, we are able to use the absorbance values that we measured to find the concentration of every substance, and vice versa. After you finish a lab and gathered all your data, your lab notebook should look similar to this.